Consider this distribution of positive and negative charges. Determine the electric flux that passes through this closed Gaussian surface. So we have a Gaussian surface right here. And we have charges on the inside of the surface and charges on the outside of the surface. This question is asking for the flux that passes through this closed Gaussian surface, which means that we're just going to be focusing on this Gaussian surface. Everything else we could disregard, okay? So we want to remember the equation to find flux. And from the last video, we know that flux is equal to the dot product. Flux is phi, symbolized as the Greek letter phi, which is this one, is equal to the dot product of the electric field and the surface area, okay? But we also can write the equation to find flux as the integral of the electric field vector times dA, so derivative of the surface area, which basically means that you want to find the charge of whatever is on the inside and divide that by epsilon naught, okay? When I first saw this, I was like, what the heck is epsilon naught? But epsilon naught, I'm going to spell it out for you so you know. Epsilon, see, now I don't even know how to spell it, okay? Epsilon, N-A-U-G-H-T, epsilon naught, okay? This is just going to be the electric constant, okay? So it means it's the permittivity of free space. So whatever you get, you're just gonna divide it to epsilon naught, okay? Make sure you get that and you'll be good. Now we want to find the electric flux, so we want to find whatever charge is inside, and to do that you just add them together. So simple, so easy. So you have, keep the signs by the way, a positive 4 plus positive 1 plus a negative 1 plus negative 3 plus a negative 5, okay? All that over epsilon naught, okay? So now 4 plus 1 is 5, minus 1 is 4, minus 3, 4 minus 3 is a 1, positive 1. Positive 1 minus 5 is a negative 4 over epsilon naught, okay? So just to fact check, okay, let me plug this in the calculator. So our answer was negative 4, right? So let's put all these into the calculator. Positive 4 plus positive 1 plus negative 1 plus negative 3 plus negative 5, you get over 1, is equal to negative 4, okay? So you have a negative 4 over epsilon naught. This is gonna be your answer, but what about your units? Your unit is going to be newtons per coulomb times meter squared, okay? Because flux, electric flux, is always newtons per coulomb times meter squared. There you go.